All right, so I'm going to use the chain rule to find the derivative of this function. F of x is x to the fifth plus 3 squared. So how I like to do this is I like to think of my inside function and my outside function. My inside function I'm going to say is x to the fifth plus 3. And that inside function is also known as u. And so my outside function would be u squared. These are my functions. And then for my derivatives, the derivative of u squared would be 2u, and the derivative of x to the fifth plus 3 would be 5x to the fourth. And so by the chain rule says the derivative of f of x would be the derivative of the outside function, evaluated at the inside function, times the derivative of the inside function. But I really just came up with that variable u, so I really need to put it back in terms of x to the fifth plus 3 times 5x to the fourth. For me, you can leave it like that. I actually might multiply the 2 times the 5 to get 10x to the fourth times x to the fifth plus 3. And really here, the algebra is not too hard. I could make it 10x to the ninth plus 30x to the fourth. And that would be the derivative there. Let me show you a similar one. I'll not use f, but capital G of x is x to the fifth plus 5 to the 100th power. Now, so my functions, my outside function and my inside function. Inside function, you know what, why don't I just make this x squared plus 3 so it's almost the same. My inside function would be x to the fifth plus 3. And my outside function would be that inside function, u to the 100th power. So the derivatives would be 100u to the 99th using the power rule, and again, 5x to the fourth. And so the derivative using the chain rule, g prime of x, would be 100u to the 99th times 5x to the fourth. But I need to not leave it in terms of u, so I'll say 100x to the fifth plus 3 to the 99th power times 5x to the fourth. And if I was going to clean that up at all, I might say 500x to the fourth times x to the fifth plus 3 to the 99th power, but then I'm definitely stopping right there. Let's look at another one. Here I've got this function h of x is the square root of 7x to the third minus 4x plus 5. Go ahead and think about what you would put for the outside function and the inside function. So for my inside function, I'm thinking what's inside the square root sign, 7x cubed minus 4x plus 5. So my outside function would be the square root of u. And then the derivatives, the derivative of the inside function would be 7 times 3x squared, so 21x squared, minus 4, that's the derivative of the minus 4x, and the derivative of plus 5 is 0. The derivative of the outside function, I could think of this as u to the 1/2, and so I get 1/2 u to the negative 1/2. And so for my derivative of capital H, I get 1/2 u to the negative 1/2 times 21x squared minus 4. It's really important I put these in parentheses. If I don't, then I get a different answer. So this would be 1/2, and instead of u, 7x cubed minus 4x plus 5 to the negative 1/2 power times 21x squared minus 4. I'm totally happy with that answer. Also, algebraically, we could make it 1 over 2 times the square root of 7x cubed minus 4x plus 5, and for that to the negative 1/2 power. And then my numerator could be 21x squared minus 4. And that, I think, is as clean as I want to make it. Let's try one more. This one is capital K of x is e to the cosine x. So what would you pick for your outside function and your inside function? Go ahead and pause the video. Try to work this problem out. When you're done, unpause it and see if you agree with me. Okay, I hope you're back and I hope you've tried it. For my inside function, I'm going to say cosine of x. Basically, I'm thinking for my inside function, what's the thing I have to work with first? And that would be, in terms of order of operations, and that would be, with x, would be doing the cosine. And if I consider that inside function u, my outside function would be e to the u. Then my derivatives, the derivative of e to the u is e to the u, and the derivative of cosine x is negative sine x. So for the derivative of this composite function, capital K, we get e to the u times negative sine of x, which I technically, I guess, could write negative e, and instead of u, I would write cosine of x. And since I already have the negative up in front, sine x there. That's how it works. Hope you got that one right. If not, the next video is going to show you some more.